You spent hours scraping a website for AI training data. Now you've got a folder full of images, video, and audio. There is just one problem. Almost none of it is actually usable. That's because multimedia scraping isn't one job. It's three, and each one needs a different approach from the start: images, video, and audio. Here's why. Let's start with images. A picture alone doesn't tell you much. You also need the alt text, the caption, the file name, sometimes the EXIF data. Without that context, you just have a folder of pixels. Now, videos. These add a new problem: time. Do you keep the whole file or put out frames? A full video keeps the timing. Frames are lighter and easier to label. The right choice depends on what your model needs. And for the audio, it's almost never the same. Sample rate, background noise, and file format all affect whether a clip is actually usable for speech or sound recognition. Getting the files themselves is the easy part. Start with an official API if one exists. If not, HTML parsing or browser automation gets you there. Video isn't always one file either. Sometimes it's streaming playlists, and dedicated tools handle the download and pull out the frames you need. If you're pulling YouTube content over and over, tools like Decodo's video downloader do wonders here. Audio often comes from a feed or gets pulled straight out of a video. Here's the part that's easy to miss. A scraper can run for weeks and still ruin your dataset. That happens when you collect the wrong version of a file: a thumbnail instead of the full image, a preview clip instead of the whole video, or audio so compressed it's barely usable. The scraper continues working, slowly losing quality along the way. The fix is simple. Check each file before it enters your dataset. Look at the dimensions, the duration, the sample rate. Spot bad files early before you waste time labeling them. That's really why you need a whole system, not limiting yourself to a single scraper. In practice, that system breaks down into 5 stages. It starts with picking your sources. A smaller source with reliable labels beats a massive one full of noisy files. Then comes collection. Fetch each file and store it with enough context to trace it back later. Next is normalization. Resize images, standardize formats, and pull out the metadata: captions, timestamps, dimensions, anything that helps you search and filter later. After that comes quality filtering, the stage we already talked about. Catch the bad files here before they cost you down the line. And last is storage. Keep your raw files separate from your clean ones, and version the dataset itself, not just your code. Sources change, and you will want to know exactly what you trained on. One more thing worth remembering: a face in a photo or a voice in a clip is personal data. Treat it that way from the moment you collect it. We covered the core of it here. For more on each stage, every obstacle we didn't get to, and the legal side in more depth, it's all written out on our blog, linked below. And if you want a reliable way to start collecting data for your AI projects, check out Decodo's web scraping API. Links in the description. Thanks for watching, and I'll see you in the next one.